Okay, so we looking at how the data is transferred from virtual memory to the RAM or physical memory as and when required. And the whole idea of virtual memory is your physical memory space is limited. So you cannot put everything onto the physical memory. You have to try to optimize only whatever is absolutely necessary must be brought onto your physical memory. So your demand paging was one way of optimizing that. Another way is this thing called copy on write. So what happens is, let's say you have two processes P1 and P2, and both of them are working with the same data, or both of them have the same set of instructions A, B and C. Now when I bring P1 from my virtual memory to RAM, I'm obviously going to bring the relevant data. So let's say I'm bringing these pages A, B, C. Now the next process I want to execute is P2. For P2 also the same pages A, B, C, the same set of instructions is what I want to be executing now. Instead of bringing the same ABC again and creating two copies of the same content in the RAM, what I'll do is I'll allow process 2 also to access the locations in the RAM which were brought in for P1's sake. So P1, we needed these pages ABC, we brought it in. Now P2 is going to do the same set of instructions. Then instead of again making copies of ABC and giving access to those copies to P2, I'll directly make P2 also access the same data or the same locations in the RAM, as long as both the functions are doing read-only jobs. So if both of them are only going to be reading from these locations, might as well ask them to use the same location instead of simply creating a copy for no reason. But if one of them wants to write, then what you'll do is you'll create a copy of that particular page, and that process gets a separate copy. Now this again is something we've discussed multiple times now. Two or more processes reading concurrently is fine, but if one wants to write, then there is a possibility of a race condition. Whether it's write read, read write or write write, there is a possibility of a race condition. So as long as both the processes are reading, you allow them to access common locations. When someone wants to write, you create a copy and you allocate the copy to one, the original to the other. So this saves space for creating, instead of creating copies unnecessarily for read-only programs. So this is called copy on write. So when you want to write, at that time you're going to copy.